Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's dive into today's daily challenge on Leetcode and try to break it down together. We have the longest unequal adjacent group subsequence one. We are given an array words. So we are given an array of strings as well as a binary array, and the binary array is either 0 or 1. If it's ith corresponding, the groups of I is 0, it means that it belongs to a particular group, and if it's 1, it means that it belongs to a different group. So I need to select a largest subsequence from the words array where the each and every group is alternating. It means that if the subsequence, let's say EAB is the words as string, then if we select E and B, both of them have the alternating zeros and ones. So yeah, let's say we are selecting A, B, C here, then A has the corresponding element as 1, B has the corresponding element as 0, and then C again has the corresponding element as 1. So it means that 1, 0, 1, 0, this should alternate always. So what is the longest such subsequence you can select from the array words? This is what is meant by this question. So if you understand the once you understand the question, I think this is going to be really easy. So if you try to think how can be the approach of this, we can try to think it in a cluster manner. Suppose you have an array of like this binary array, some ones, some zeros, like this. So you can think it as a, first we have some cluster of zeros, then we have some cluster of ones, then we have again have some cluster of zeros. So in this manner you can think that there is some cluster, and for each cluster I can take exactly one word from the words. There can be multiple answers definitely. So what we will do is that whenever there is a bit change from 0 to 1, suppose I will check that now current bit is different from the previous bit, then we will select the word corresponding to the current bit. So let's say I have something, let's say the first, for to the first 0 I have the string, let's say my, then uh, the second, let's say phone I have, then I have is, then I have is very, then I have good, something whatever, let's say Titanic, something like that. So we have some list of words. So let's say my corresponds to 0, phone corresponds to 0. So first we will always take my, and then whenever the bit is flipping from phone to is, there is a transition from 0 to 1, so we will take is. Then again from 1 to 0 there is a transition when there is very to good, so we will take good, because from very it was 1 and good it's 0, so there is always a transition. The first bit always I will take. So this is how we can approach the problem. It will be very easy to code it out. We have the n word size, and what we need to store is the previous value. Previous value is nothing but uh, not word, groups of 0. You have the vector of string, you have the vector of string answer. You need to push back, always the first element will be the answer. As I told you, there must be at least one value, the first element. So it should be words of I am assuming it has at least one length. And now we will iterate from I equal to 1 to n, not 0 to n, because the first thing we have already taken care of. I will see that if this groups of I, the binary value corresponding to the groups of I, if it is not equal to the previous value, then only we will answer dot pushback this groups of I. Okay, answer has the words value, and then we will also update the previous value in every iteration. So I think that would be sufficient for the problem. The previous value is nothing but groups of I in the as the ith iteration finishes, and just we return answer. So I think that would be sufficient. So yeah, let's just try to run it. We do have this accepted. Let's try to submit it. So yeah, we do have the accepted thing. I think once only this problem description can be difficult to understand, but if you try to just read it properly, I don't think it's any difficult. And approach the everything, the solution coding is quite easy in this problem. So it was a very easy problem for today, and I hope your day is going to be very easy too. Thank you so much.